Let's see this question, sir. Given what? The inverse of Q symmetric matrix of odd order. Given symmetric, Q symmetric, diagonal, none. I will say not only none, does not exist. We can say that one also. See, Q symmetric matrix annaru, that to inverse kavale, that what? Odd order. What is Q symmetric matrix? A transpose equals to minus A. We given one statement for Q symmetric matrix. Q symmetric matrix of odd order matrix determinant. In determinant, properties of determinant, last property I given. The determinant of Q symmetric matrix of odd order always is going to be 0. Mari determinant Q symmetric matrix the odd order the 0 aithe inverse untada? No inverse. That's why if you are asking inverse, the answer is going to be does not exist. We'll see here also once again. That is, if you take determinant both sides, determinant of A transpose always is going to be determinant of A only. I can say this is as minus 1 into determinant of A. That is minus A is nothing but minus 1 into A. Always Ka determinant equal to K into determinant of A. Minus A this side plus A, that is 2 determinant of A equal to 0. From there determinant of A equal to 0. Determinant 0 aithe inverse anedi does not exist. Does not exist. We can't get inverse for Q symmetric matrix of order. Simple statement, just I given as a question. It is also asked in ECET. If you are asking, if you giving one matrix, that to Q symmetric matrix, that to 3 by 3 given. Q symmetric means you know, that is what? Determinant of A equal to minus A, and also we given, we see in properties of symmetric and Q symmetric matrix, that is transpose of a matrix. Always diagonal elements are going to be 0, remaining elements are going to be in additive inverse. If like that you are getting one question, if you are asking that inverse for that, simply option is going to be does not exist. See here also simple questions, it is also asked in ECET. If A is orthogonal matrix, this is okay, A is orthogonal matrix, then determinant of A is what? Orthogonal matrix is nothing but already we said, that is orthogonal means when we will say orthogonal, A into A transpose equal to A transpose into A equal to I. AB equal to BA equal to I, that is different. Here that is inverse. Here if you multiply one matrix with transpose, if you are getting identity matrix, then that A is said to be orthogonal matrix. Based upon that he asked, what is determinant of A? Simply I am checking A into A transpose equals to I. Once again I am taking both side determinant A into A transpose determinant equal to determinant of I. We know very well determinant of AB always is going to be determinant of A into determinant of B. From there determinant of A into A transpose equals to determinant of A into determinant of A transpose equal to determinant of I always is going to be 1. Already we know determinant of A transpose equals to determinant of A only, that is determinant of A into determinant of A equal to 1. From there determinant of A whole square equal to 1. Now determinant of A equals to what? Simply plus or minus 1. Not only 1, you are going to get minus 1 also. 1 on the minus 1 on the, and one more option at last we having plus or minus 1, that is going to be your answer. If we given only one number, only plus 1, that is going to be answer. If we given only minus 1, that is going to be answer. If he is giving a plus or minus 1, that is going to be answer. This question is asked previously like what means he given the question as if A into A dash equal to I, then determinant of A equals to what? Same question. He given this statement and asked. Ikkadana confusion ఉంది, ఆర్థోగోనల్ అంటే తెలవాలి. ఇక్కడ ఆర్థోగోనల్ తెలవాల్సిన అవసరం లేదు. సింపుల్గా A into A transpose ఈక్వల్ టు I ఇచ్చేసినారు. ప్రాసెస్ ఫాలో అయితే మళ్ళీ వచ్చేది ఏంది ఆన్సర్? ప్లస్ ఆర్ మైనస్ 1. Okay, this is 2017 question. Let's see this question here. Given A is asking what? Argent of A. Argent of మరి ఒక మ్యాట్రిక్స్కి అర్జెంట్ ఫైండ్ అవుట్ చేసి మళ్ళీ అర్జెంట్ ఫైండ్ అవుట్ చేస్తే ఏమొస్తుంది? యూ కెన్ రైట్ here simply the year 6, year 3, year -4, once again interchange. But I am giving by using property. Let's see this. We know I given one property, argent of A whole inverse equals to A by determinant of A. Means to find argent of A whole inverse, simply you have to divide each and every element with the determinant, you are going to get an answer. Okay. Here argent of A whole inverse. What is A inverse formula here? What is A inverse here? A inverse formula is what? Simply A inverse equal to 1 by determinant of A into argent of A will write. With this formula I am modifying this. Argent of A whole inverse. In place of A we are having argent of A, that is 1 by determinant of argent of A into argent of A. This is matrix, this is number, equal to A by determinant of A. Let's see what is argent of A if it is 2 by 2 matrix. It is 2 by 2 matrix. Then what? 1 by, just before only given argent of A matrix, determinant always is going to be determinant of A only for 2 by 2. Argent of A equal to A by determinant of A. Simply cancel na. What? Argent of A equals to argent of A always is equals to A for 2 by 2. For 2 by 2. If you find argent, very less time you will get A, B, C, D. Simply argent matrix D minus B minus C minus plus A. That you will write. Once again if you write argent, you will get same matrix. If you want, you can check. For this, answer is going to be A. For 3 by 3, it is going to be different. 3 by 3 you will get here determinant of A whole square. Oka determinant cancel aitadi. Indirectly one more determinant. A into determinant of A. Argent of A for that is going to be determinant of A into A is going to be for 3 by 3 matrix. By using this, just we said for 3 by 3 you can do. If you want, you can take for 3 by 3 also, you will get an answer. Okay. Let's see other problems.